Hello girls and guys, and welcome to this interesting lecture. In this lecture we're going to talk about the cost function or mean square error or square error function. And I know that you might be thinking that, hey Ayush, what do I call it? You can call it any the way you like. You can call it as a cost function or mean square error or a square error function. All the means the same. Only the thing that I also, when I was the beginner, I was just kind of confusing that what is cost function, what is mean square error, and what is a square error function. It just confused me a lot. But I think that they are all the same: cost function, mean square error, or a square error function. Okay. Now let's come on to the topic. That what we are going to study in this video. In this video, we're going to study about a cost function, intuition behind the cost function, and at last but not the least, we will implement our model that we have learned till now in Python programming language. Okay. Now first of all, let's define what is a cost function. A cost function is nothing that we have a parameters theta 0 and theta 1, and I have told in the previous video is that for checking the accuracy of our best fit line, so-called best fit line, or for linear regression best fit line, or theta 0 and theta 1, we have our favorite cost function, or in simple terms we can say that it actually checks our machine learning model how it is. It is good or bad. Just a small recap. Okay. Now let's take one example to get you more handy with cost function. Let's say we have a theta 0 equals to 2 and theta 1 equals to 2. Theta 0 equals to 2 and theta 1 equals to 2. I have taken from previous video and just map it on the hypothesis function, and we are going to get this. And this is our model. And this is our model. And for checking the accuracy of our model, we have our cost function. Okay, and you can just provide the input value and our output value will come. But who can guarantee you that it is a good that your model is good? So for checking the accuracy of our model, we have our cost function. I have repeated them 100 times. Okay, not 100 times, two times. Okay, 2 times I have implemented. Okay, now let's see how we can compute the cost function. So for computation of our cost function, we have this equation, a very pretty much easy equation that I have ever seen in my machine learning journey. That it is very pretty much easy, but some of you have been finding this a very complex. But wait for some time, I'll break it apart and make you understand step by step. First of all, what is J here? First of all, what is J? J confuses a very lot. J is the cost, is the name of the function for theta 0 and theta 1. Okay, theta 0 and theta 1. And actually computation works from here. Okay, now let's break it apart. 1 by 2m x bar. It means the mean. Okay, now let's understand by breaking this equation above. Then here, first of all, in x bar, what we are in the mean, it's actually called the mean. It's actually called the mean. Just don't judge me. Okay, it's a mean. What we are doing is that we are taking the mean of the squares, mean of the squares of h of xi and yi. And what is this? It is the difference between the predicted. It is the difference between the predicted and the actual value. Okay, what is doing this line contains whole about that. What is doing? It is mean of the squares. It is mean of the squares of the h of xi and yi. At this mean of the squares of h of xi and yi, and it is nothing but the difference between the predicted and the actual value. Okay, now what is this 1 by 2m? What is this? That we are doing half of the mean. So let me take the pen. What we are doing the half of the mean, 1 by 2m of our mean, that is this. And because for the convenience computation for our gradient descent, it will cancel out later. It will cancel out later when we do the mathematical computation here. But just understand that 1 by 2m is only used for computation for a gradient descent. But if you're not understanding, just it's okay. When you get familiar with the gradient descent, it will be familiar with the cost function also. So let's keep it aside. Just understand the topic 1 by 2m, and this main concept is here is that we are taking the mean of the squares of the difference between the predicted and the actual value. The notes, all this will be given in the description box below, so be sure to check it out. Okay, no worries about it. Just again explaining you that we have what we are doing half of the mean of the squares of h of xi and yi, which is nothing but the difference between our predicted and the actual value. And let's do one more. Let me give you the intuition behind the cost function, which give you more come handy in this cost function. So let's say we have this kind of example here, and now let's see the intuition, what the cost function is actually doing. Let's say we have this point here is our actual value, and this line here is that we have this here is that we have predicted value. So what it's doing is that it is taking the difference between the predicted and the actual value and taking the mean of that, and then it is doing half of the mean. Understand, it is taking the difference between the actual and the predicted and the actual value, and then what it's doing is that taking the mean of this, and then it is doing half of our mean, which is like this, and we got our cost function just like this. Okay, nothing to worry about it. So I think that you got a bit of intuition about a cost function. Just one more explaining one more time is that here the blue one is the actual value, and the white, the straight line, is the predicted value. And what we are doing, we are taking the mean of the squares of our difference between the predicted and the actual value, where the predicted value is the line here and the actual value is the blue points here. Okay, and it's doing nothing. Okay, now, and it is doing just like this. Okay, now let's see our model that we have built till now. Our model we have built till now is hypothesis, and then we have the cost function, which is something like this. Again explaining you, we are taking the mean of the squares of the difference between the predicted and the actual value, and then we are doing half for the convenience computation for the gradient descent. Okay, let's not worry about it. And one more thing is that we have our goal. Yeah, our goal is main thing, that we have to minimize our cost function. Yeah, we have to minimize our cost function that we have to take a look at just now. So we have our cost function. It is also called a mean square error. It means it is something related to error. And our goal is to always minimize this error, not to maximize this error. We don't have to maximize this error. Our goal is always to minimize this error so that our model accuracy should be good. Okay, so that's why our goal is to minimize our cost function, which is j of theta 0 and theta 1. And also I have to do some computation here, is that what you can do is that you write, instead of writing theta 0 and theta 1 times x, you can simply write theta 1 times x, because just add this both and you can write theta 1 times x. It's okay. Okay, and yes, you can write theta 1 here also, and yes, you can write theta 1 here also. Not in, okay, yeah, you can write it theta 1 here also. Let's not worry about it, but whatever you want to do, you can do. Okay, now we have learned about a cost function. I think that you got a better intuition about the cost function. In case you haven't understand, comment below so that I can solve your queries in the description box below, or I will make a video upon that if it's get required. Okay, now it's time for implementation of our model that we have implemented till now. So let's get into the Jupyter notebooks. Now I'm on my Jupyter notebook. So first of all, let's define our compute cost, and it takes x comma y and theta, and here m equals to the length of the y, and we have predictions, which is used for the difference between the predicted and the actual value, which is equals to the x dot theta here. And another thing that we can do is squared error, and we can think of it as for squaring the error, we can simply just in bracket predictions minus our y and squaring it up, and at last we have to return our 1 divided by 2 times m times our this mean of np dot sum. Sorry, well, why have I written this? Np dot sum of squared. Okay, now if I run this and we have implemented our cost function, it's good to go. Okay, so that's it for this video, and I will be meeting you in the next video.